Okay, so let's look at something that I believe is quite interesting. Okay, so we need to find the general formula for the nth derivative. Okay, so sometimes it can be written as f n like that derivative of x, or sometimes it's just written as nth derivative nth derivative like that. It means one and the same thing. So what is really the nth derivative? What does it talk about? What are we able to understand from the nth derivative? Okay, so the nth derivative is it gives us a pattern that the derivatives that you're going to have are following. For example, you're going to have your first derivative, your second derivative, your third derivative, your fourth derivative, your fifth derivative, your nth derivative. So meaning, sometimes maybe let's say you are asked to say find the 20th derivative. You don't really have to start differentiating one by one until you reach the 20th derivative. You need to have that formula that helps you to do what to find that 20th derivative without you having to differentiate step by step, starting from the first, second, third, fourth until you reach the 20th. Okay, and that pattern we just get it from we look at the behavior from the first one to the second one to the third one to the fourth one, the fourth one to the fifth one. But usually the pattern is observed starting maybe from the third one going below here. Okay, so that is what we want to try to find out in this case. So we having said that, we're able to understand that for us to get that pattern, meaning we have to differentiate multiple times. Okay, so for this one, I will try to differentiate up to the fifth term. Okay, so that we try to get to obtain a pattern. All right. So um, our f of x, okay, our f of x can also be written as what? Can also be written as a plus bx to the power negative 1. Okay, so differentiating that for the first derivative, it's more like I'm using chain rule here. So I'll have my negative 1 here, open bracket, not really open bracket. I'll differentiate what is in the bracket here as my u. What I'm going to get is a b. I close a plus bx minus 2 here. Remember to say when you're differentiating, that one there is going to reduce by 1. Okay, so what you end up having is just a minus b. Okay, we get minus b is equals to that. Okay, so that is our what? Our first derivative. So our second derivative, what are we going to have? So for the second derivative, we do the same. The negative 2 is going to multiply the constant there, which is our b. That is going to be positive. We're going to say 2 here, b. Then again, we're going to multiply what we have by the derivative of what we have inside, which is a b, meaning we have a what? A b squared. And we have what? A plus bx the power negative 3 like that. The third derivative. The third derivative is going to be the negative 3 multiplied by what we have there. That would be minus 6b. Then the b squared there multiplied by the derivative of what we have inside, which is going to be to the power 3 open bracket a plus bx minus 4 like that. So we say y to the power, the fourth derivative in this case, what you're going to have is the negative 4 we multiply by the negative 6. What you're going to get is something like a 24. Okay, we get a 24 here, b. So now we have the b to the power 3 here multiplied by the b, which is the derivative of what we have inside. That would be our b to the power 4. Then we have our a plus bx minus minus the power 5 there. Okay, so for the fifth one, y to the power 5, what you're going to have is minus something like 120 b to the power 5. I believe we now know the steps. Just follow the same pattern. b to bx to the power negative 6 like that. So now we want to try to come up with a formula that we are supposed to use to easily find whatever n value of the derivative that we need to find. Okay, so now I'll try first of all to observe the behavior of the coefficient. Okay, the coefficient, which is our b there. So in terms of the b, I see to say everywhere I have b, 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 I have a b, but there are times when our b is negative. There are times when our b is what? Our b is positive. Okay, so we saw to say when our n is 1, we have a negative. Then when it comes to the second one, of course, I think let me just ignore the first one. Let me use the second one, the third, and the fourth, the fifth, just like that. So when I see on the second one to say when my value of n is an even number, what I have here is a positive. Okay, when I have an odd number, I have a negative. I have an even number, which is 4, I have a positive. I have an odd number, 5, I have what? I have a negative there. So what are we able to derive from that? So what we're able to derive is that when you put negative 1 like this, then to the power n, when you put when you place with a 2 here, what you're going to have here is a positive. Okay, so that's the pattern in terms of what? In terms of the sign. Okay, so what about the b? B is just changing in terms of what? B is just changing in terms of n, because when you have 2 here, we also have 2 here. We have a 2 here. I mean, we have a 3 here, also have a 3 there. So the b is just changing in terms of the what? The n value of the derivative. So let's try to focus on what? On this one here, the 2, the 6, the 24. How are they changing? We have a 2, we have a 6, we have a 24, we have a what? 120. So these are basically what? And besides, we have what? We have a 1 here. So this is just basically a 1 factorial here. We have a 2 factorial. We have a what? No, not putting it like that. uh Supposed to be the other way around. We have a 1, a 2, a 3, a 4, and a 5. So we have a 1 factorial giving us a 1, 2 factorial giving us a 2, 3 factorial giving us a 6, 4 factorial giving us a 24, 5 factorial giving us a what? Giving us a 120. So meaning we are saying here we are going to have n factorial. Then for b, we're just saying is b to the power what? B to the power n. Then what are we going to have in the brackets? We observe to say in the brackets nothing changes. The only thing that changes is what? Is the power there. Okay, so what do we have? We can say open bracket. We are still going to have a plus bx. We close. Then to the power is minus n minus 1. Okay, when n is 1, okay, when n is 1, you're going to get negative 2. When n is 2 here, when n is 2, we get what? Negative 3 there. Okay, so now we can say our y to the power n of x, okay, is equals to we can say negative 1 to the power n, then n factorial b to the power n divided by a plus bx to the power n plus what? Plus 1 nd. That's the what? That's the pattern that those derivatives are following there. Okay, so if you'd want to try this out, let's try to pick the fifth one. Okay, let me just get rid of these others. We try to use the what? The fifth one. All right, the fifth one. So for the fifth one, the value of n is equals to 5. Okay, is equals to 5 there. So meaning when you say y to the power 5, or the fifth derivative, okay, the fifth derivative there, what you're going to get is we say open bracket 1 there, negative 1 rather, then you put 5 here, then 5 factorial, then b to the power 5 divide by a plus bx, then 5 plus what? Plus 1. What do we get? Negative 5 to the power 5 is still negative 1. Then multiply by 5 factorial is 120. Okay, it's 120. So you get minus 120. Then b, we just put it the way b to the power 5 the way it is, divide by a plus bx to the power what? To the power 6, of which this one and this one are not different. We have a negative there, so we just have to bring it on the denominator. That's why we have what? We have that like that. So that's how you go about coming up with the nth derivative of a given function. So it's just a matter of taking things step by step and be open-minded. Don't restrict yourself too much. Try to think as much as you can, but again, don't confuse yourself. Okay, because sometimes they find that the answers that you're looking for are just within your fingertips or within your same your calculation or what you're trying to derive. Okay, so that's all in this video. And just in case you have not subscribed to our channel, please subscribe and like. And in case you have anything that you'd want to try to find out from us, you have a question or anything related, of course academic related, feel free to drop it in the comment section and we'll be able to attend to you in the quickest time possible. And if you'd want to get in touch with us, you can call, text, or WhatsApp us on this contact 0974004921. So just drop a text, call, or WhatsApp, anything. We are very much available 24 hours to make sure to say we'll be of help to you in any way that we can. Thank you very much for watching.